What hidden language structures do NLP models learn to exploit? Imagine a computer that can understand and generate human language almost as well as a person. How does it do that? Well, it learns to recognize patterns and structures in language that are not obvious at first glance. These hidden structures are what make natural language processing models so powerful. At the simplest level, these models look for statistical patterns. For example, they learn which words often come together or follow each other. This is similar to how you might notice that the word cat is often followed by meows or sits. Older models like Hidden Markov models focus on these probabilities to guess what word comes next or what part of speech a word might be. They use the likelihood of certain sequences to make predictions. More advanced models, like those based on masked language models, such as bidirectional encoder representations from transformers, or BERT for short, learn to predict missing words in sentences. By doing this, they understand how words relate to each other in context. For example, if the sentence is "the cat sat on the model predicts the missing word based on what makes sense, like mat. This helps the model grasp syntax and meaning at the same time. Deep learning models like transformers, which power systems such as ChatGPT learn layered representations of language. Think of it as building a hierarchy. The lower layers focus on individual words and their features. The middle layers understand how words connect through grammar and meaning. The top layers combine everything to understand the overall message of a sentence. This layered approach allows the model to see both the small details and the big picture. These models also learn latent structures, which are hidden patterns like grammar rules, phrase boundaries, or how ideas are combined. They do this without being explicitly told what the rules are. Instead, they find these patterns by analyzing vast amounts of text and noticing what words and phrases tend to go together. Knowing these hidden structures helps NLP models perform many tasks. They can generate text that makes sense, translate languages accurately, summarize long articles, or answer questions. For example, ChatGPT uses these learned patterns to produce responses that fit the context. Even image-generating models like DALL-E or Midjourney understand text prompts by interpreting the language structures they have learned, allowing them to create relevant images. From an ethical point of view, it's important to remember that these models learn from data that can contain biases. Because they pick up on patterns in the data, they might also reflect societal stereotypes or unfair biases. This is why transparency and careful oversight are necessary when deploying these models. In the end, NLP models learn to exploit hidden language structures like statistical word patterns, syntactic and semantic relationships, and layered representations of language. This enables them to understand and generate human-like language without needing explicit rules. These capabilities form the core of many AI tools we see today, making language processing more natural and useful than ever before.